Hello everyone, I am Mrs. Sunita Dole. The topic covered here is relational database design, features of good relational design and first normal form. In general, the goal of relational database design is to generate a set of relation schemas that allows us to store information without unnecessary redundancy, yet also allows us to retrieve information easily. This is accomplished by designing schemas that are in appropriate normal form. In this video, we are going to cover features of good relational design, the meaning of atomic domain and first normal form. Learning outcome. At the end of this session, students will be able to list and explain features of good relational design. Apply first normal form to the given example. Features of good relational design, design alternatives, larger schema. Now let's explore the features of this relational database design as well as some alternatives. Suppose that instead of having the schema instructor with the attribute ID, name, salary, department name and department relation with the attribute department name, building and budget, we have the schema instructor department with the attribute ID, name, salary, department name, building and the budget. This represents the result of natural join on the relation corresponding to the instructor and the department. Consider the instance of instructor-department relation. We have to repeat the department information such as the building and the budget once for each instructor in the department. For example, the information about computer science department, that is building, teller and budget 1 lakh, is included in the tuple of instructor cards, Srinivasan and brands. It is important that all these tuples agree as to the budget amount, since otherwise our database would be inconsistent. Using instructor department is bad idea, since it stores the budget amount redundantly and runs the risk that some user might update the budget amount in one tuple but not all, and thus create inconsistency. In our original design, using instructor and department, we store the amount of each budget exactly once. There is still another problem with the instructor department schema. Suppose we are creating a new department in the university. So in the alternative design above, we cannot represent directly the information concerning a department with the attribute department name, building and budget unless that department has at least one instructor at the university. This is because the tuples in the instructor department table requires the values for ID, name and salary. This means that we cannot record information about newly created department until the first instructor is hired for the new department. In the old design, the schema department can handle this, but under the revised design, we would have to create a tuple with a null value for the building and the budget. Design alternatives, smaller schema, lossy decomposition. A real world database has a large number of schemas and even a large number of attributes. The number of tuples can be in millions or the higher. Discovering repetition would be costly. The database designer needs to recognize the situation where the schema ought to be split or decomposed into two or more schemas. Finding the right decomposition is much harder for the schema with large number of attributes. Not all decomposition of schemas are helpful. Consider an extreme case where all we had were schema consisting of one attribute. No interesting relationship of any kind could be expressed. Now consider a less extreme case where one chooses to decompose the employee schema with the attribute ID, name, street, city and salary into following two schemas: employee 1 with the attribute ID and name and employee 2 with the attribute name, street, city and the salary. The flaw in this decomposition arises from the possibility that the enterprise has two employees with the same name. As an example, let us assume two employees, both named Kim, work under the university and have the following tuples in the relation on schema employee in the original design. Figure shows these tuples, the resulting tuples using schema resulting from the decomposition, and the result if we attempted to regenerate the original tuples using natural join. As we see in the figure, the two original tuples appear in the result along with the two new tuples that incorrectly mix data values pertaining to the two employees named Kim. We can indicate that certain street, city and salary pertain to someone named Kim, but we are unable to distinguish which of the Kims. Thus, our decomposition is unable to represent certain important fact about the university employees. Clearly, we would like to avoid such decomposition, and we shall refer to such decomposition as being lossless decomposition. Now consider a case where we choose to decompose the employee schema with the attribute ID, name, street, city, salary into following two schema: employee 1 with the ID and name, and employee 2 with ID, street, city and the salary. Figure shows these resulting tuples using schema resulting from the decomposition, and the result if we attempted to generate the original tuples using natural join. As we see in the figure, the two original tuples appear in the result of natural join. This is lossless decomposition. Consider the example for lossy and the lossless decomposition. So, relation R with the attribute A, B and C. R is decomposed into two relation R1 with the attribute A and B and R2 with the attribute B and C. Figure A shows the lossless decomposition, the resulting tuple using schema resulting from the decomposition, and the result if we attempted to regenerate the original tuple using a natural join. The common attribute B has different values, that is 1 for first tuple and 2 for second tuple. As we see in the figure, the two original tuples appears in the result of natural join. Figure B shows the lossy decomposition, the resulting tuples using the schema resulting from the decomposition, and the result if we attempted to regenerate the original tuples using a natural join. As we see in the figure, the two original tuples appear in the result along with the two new tuples that incorrectly mix data values pertaining to the two B values 1. Atomic domain and the first normal form. So, first atomic domain. A domain is atomic if the elements of the domain are considered to be indivisible unit. Composite attributes such as the attribute address with the component attributes street, city, state and zip also have non-atomic domain. Integers are assumed to be atomic, so the set of integer is atomic domain. However, the set of all sets of integer is non-atomic domain. Atomicity is an actual property of how elements of domain are used. Example, the strings would normally be considered indivisible. Suppose that the student's roll number are written like CS0012 or EE1127. If first two characters are extracted to find the department, the domain of roll number is not atomic. Doing so is bad idea, which leads to the encoding of information in the application program rather than in the database. Now consider the first normal form. A relation schema R is in first normal form if the domain of all the attributes of R are atomic and the value of each attribute contains single value from domain, that is no multi-valued attributes. Example, consider a database to store the information about students who appear for course and the score marks. A student has name and 2 telephone number. A student can appear in many courses and is allowed to take exam only once per course for which he is assigned marks. The marks determines the grade of student. So consider the student database with the attribute ID, name, contact number, course, marks and the grade. In this database, we observe that this table is not in 1NF as it does not satisfy both the criteria, that is multiple values of telephone number are stored in the same attribute contact number, and the name attribute is not atomic. For each name, first name and last name is mentioned. So split the name attribute into two attributes, fname and lname, for storing first name and last name respectively. We'll also split the contact number attribute into two attributes, one for mobile number and other for the home number. This leads us to the student mark table provided below. Second way to convert this student marks table to the first normal form is given below. Consider the separate table student contact for storing the contact information. This table will consist of student ID and mobile number. The primary key for this table is the union of student ID and mobile number along with student ID as a foreign key referencing student ID, the primary key of student marks. Till now, we covered the features of good relational design, atomic domain and first normal form. Now pause this video and reflect on this question for a minute or 2 minutes and write your response. Once you return the answer to this question, then you can restart playing this video. Example is, Sweet Home Company needs to create a normalized database to store rental information about its client. A property can be rented to a client for specific duration. Each property has an address, an owner and the rental value. The database should allow search based on client name, owner name, city and rental duration in month. Sample data for this application is provided below in a normalized form. Normalize the database to the first normal form. I hope all of you have completed this activity. The above relation is not in 1NF as rent duration is not atomic. We make the assumption client name and address attributes are simple attribute. So split the rent duration attribute into two attributes, rent from and rent to. This leads us to the property rental information table provided below. Now this table is in first normal form. This is the reference used while preparing the presentation. Thank you.